Hi, class. There is an item that our textbook didn't really cover that is in your problems, and I wanted to talk about it. And that has to do with many-to-many relationships. So here is an example. We have two tables. One table contains information about artists, recording artists. So we have an artist ID and the artist first name and last name, and of course many other attributes that have to do with artists. And we know that an artist can be in a band or many bands. And here we have our band entity. Right now, we're just displaying our band ID and the band name. When we look at our band entity, we know that a band can be made up of many artists. So here we have many-to-many relationships. I've shown them as two different relationships because really that's what we have, right? The relationship of artists to many bands that they could be in. I would like to list all of those bands. And then the relationship of a given band to many artists that could be in the band. So whenever we're working with our entity relationship diagram and we have something like this, it can be hard to explain, and that's because it's a situation that exists in nature. It's a natural situation, a natural relationship, but it's not a relationship that's easy to implement within a database structure. Because if I were to add an attribute to my artist table, let's see, how do I do that? I got to get just in the exact right place, right? Come on, you can do it. My new attribute then, if I said it was going to be band ID, so that I would be able to look at a row in my artist table and know what band that artist were a member of, that would work great if this were a one-to-one relationship, right? Because one artist in my artist row could have one band that belonged to my band row. But we know that there exists the ability to have many band relationships. So we can't just have one band ID associated with one artist. It's an illogical situation. So I cannot actually include that attribute on my artist table, at least not correctly. So let me get rid of it. So what can I do? Well, I can create a join attribute, a link table. So I'm going to grab another entity and add this to my diagram. Let's call this entity band member. Now we could call it artist band, band artist. Oftentimes we'll see that kind of relationship. Now within our band member entity, I'm not going to worry about the primary key right now, and I want you to really even worry about that. But I am going to say that this table would have one entry for every artist. Whoops, sorry, I changed the wrong thing here. And every band. So I would have one row in my table every time there was an artist that belonged to a band. So I could have, one artist be in several different bands or vice versa. Now, how would I change the relationships to accommodate this? Let me delete these. And I'm going to move this entity into the middle. If I could go back to my pointer tool and rearrange things just a little bit. Put my artist up here a little higher. my band member underneath, and my band down below. Now, there's no set rules for setting up an entity relationship diagram, but it's nice for us to keep things organized where our relationship lines don't cross each other, etc. So I'm going to grab my relationship, and the first relationship I'm going to have in this new setup is I'm going to say that I have a relationship between a band member and an artist. Now I would like this relationship line to be a little bit wider. That looks pretty good. And I need to change the connector types. So my arrows, my begin arrow is going to be my artist, I think. And I'm going to have one artist that can belong to many bands. All right. And then I need to have another relationship from my band to my band member. Notice I started at my band and then drug that connection to my band member. So on my band, that should hopefully be my begin arrow type. And I'm going to say one band can have many members. Let's thicken up that a little bit so we can see it better. How's that look? Now, if I were to think about this from a row point of view, I would be able to have a row in my band table for every band. So I could have one for the Rolling Stones and one for the Beach Boys and one for Green Day and one for whatever band that I wanted. Just one row for each band though, right? Because if they decide to change their name or something, I only want to have to change it in that one row. Now, within our band member table, we could have one row for every instance of an artist being in a band. So if I'm looking for Billy Joe Armstrong, I could find his artist ID associated with the band ID for Green Day. If he were ever in any other band, I would be able to find another row out there for him with that situation. And then my artist themselves are going to be associated with many different bands. So let's label these relationships. I could say artist belongs to, or an artist becomes a band member. And then I could say that a band has many band members. And that would kind of identify those relationships. Okay, so to summarize, whenever we have a many-to-many relationship that exists in nature, we have to resolve that many-to-many relationship by adding in a link table. And the link table takes the many-to-many relationship and changes it into two one-to-many relationships. So now I'm saying for one artist, I could have many bands. For one band, I could have many members. And that way, I can actually support that sort of relationship in the database. Now, our link table could actually have additional data. It could carry data fields like the date the band member joined, or the instrument that they play, because we know that they could play different instruments for different bands. So we might actually find that data logically belongs to our band member entity as we work further in the design of our database. But I just wanted to show you that this is how we resolve a many-to-many relationship in our early design. Thank you.